Now, we have worked with operators before, for example, the assignment operator that we know and love, where, for instance, we take this integer variable x and we assign it a value of 9. And we've talked before about how this assignment operator works with two different operands. It works with this 9 and it works with this x. And how it works is it just takes this 9 and sort of plugs it into this x. And well, that's the assignment operator in a nutshell. Well, there's another family of operators called relational operators, and these are super important when it comes to decision making in your program and having your program make decisions for itself. And that's the next topic that we're going to talk about. But before we can get into it, we need to discuss how relational operators work. Now, these operators sort of look like the less than sign, the greater than, the less than or equals, the greater than or equals. This is the equals relational operator. Notice that it has two equals symbols instead of just one, which is the assignment operator. And then the not equals relational operator. Now, a side note, not can be denoted with an exclamation point in more cases than just this. Not in general is denoted by this exclamation point, but altogether here, this is the not equals relational operator. And these, like the assignment operator, work with two different operands. Like, so for instance, this less than relational operator will take a statement like, is A less than B, right? And if A truly is less than B, what will happen is that this relational operator will return a 1, indicating that this is a true statement. Now, if A is greater than B, well, the statement that A is less than B would then be false. And well, in that case, it'll return a 0, indicating that that is a false statement. And all of these sort of work in a similar fashion, just comparing two different values based on if they're less than, if they're greater than, if less than or equal, or so forth. And so let's see this in action, because once you see it in action, it'll be super intuitive. And so we're just going to see out to the screen, say, we're going to test the condition that 2 is less than 4. Well, that is a true condition. 2 is indeed less than 4. And when we run this, well, we get a 1 printed out to the screen because that is a true statement. 2 is less than 4. But say, for instance, we say 7. Is 7 less than 4? Well, that is a false statement because 7 is not less than 4. And when we run this, well, we get a 0 as an output because that is false. 7 is greater than 4. So let's get a little tricky with it. Well, let's say, is 4 less than 4? Well, that, as it turns out, is false because 4 is equal to 4. 4 is not less than 4. And all of these sort of work like they say on the 10. They test if A is greater than B, A is less than or equal to B, A is equal to B, A is not equal to B, and so forth. And so let's do a tricky one here that trips people up sometimes when they're first using it, the not equals one. And so we can say, see out to the screen, we're going to make the assertion that 3 is not equal to 4, right? Well, that is a true statement. 3 does not equal 4. And so here we see that a 1 prints out to the screen because 3 is not equal to 4. Well, let's do a different one. We'll say 4 is not equal to 4. Well, that is a false statement because 4 does equal 4. And so there you go. There is your false there. Now, we've been using integers this whole time, but as it turns out, you can compare other data types. Like, for instance, we can say 1.2, and we'll say is greater than 1.1. And so this would be a true statement because 1.2 is greater than 1.1. And well, there you go. It is true. Now let's make it a little tricky, and we'll say, is negative 1.2 greater than negative 1.1? Well, now that is a false because, well, negative negative 1.2 is technically smaller than negative 1.1. See what I'm saying? There's also another little nuance here that you need to be aware of when you're dealing with floating point numbers, that rounding errors can introduce a little bit of wonkiness depending on what you're working on. So we can say, for instance, is 0.9999 less than, say, 1.0? Well, it is. And so when we run this, this should be a true statement here, and we do get our true out of it. However, if we add a bunch of nines to this and make this a longer number, this is still technically true. 0.99999 off to however how long we have it is less than 1. Well, technically, yes, that's still true. But when we run this, we see that we get a false output because C++ consider these numbers close enough at this point. And if you're working on an application that deals with astronomical figures, and this might be way off as far as you're concerned, then you need to deal with that in your code and be aware that sometimes with floating point numbers, if it's close enough, you may get weird answers out of this. And so you have to account for that in your coding. Now, the other neat thing is that this will also work with, say, characters. You can put things in alphabetical order with these relational operators. So we can say, is A less than B? And notice I'm putting these characters in single quotes because we're dealing with characters here. And so when we run this, true, A is less than B. Now, is F, for instance, less than B? Well, that would be false because, well, F is not less than B. But another thing I want to point out here is that you have to be careful when you're dealing with letters that are both capitalized and uncapitalized. So, for instance, when we run this, is A less than B, that is false in this particular condition because, well, A really is less than B as far as we're thinking. I mean, if we're trying to put things in alphabetical order, but this actually runs off of not the letters themselves, not the characters themselves, but their ASCII representations. Like, so for instance, as far as ASCII is concerned, we can see out to the screen, let's say the integer representation, the ASCII representation of, say, A, and then we can drop down a line and see out, we'll say, the integer representation of a capital B, and then drop down a line, and you'll see why this result is the way it is here, even though that's not what we expect, because the ASCII representation of a lowercase a is 97, and the ASCII representation of an uppercase b is 66. And so if you're going to ask if 97 is less than 66, well, then that is a false statement because 97 is not less than 66. But if you're thinking in terms of characters, you might be surprised that A is not considered less than B in this situation. Well, that's because one of them is capitalized and one of them is not, and that's why you get that result. And we'll learn more about how to fix this later. Just wanted you to be aware for the time being that this may result in some sort of weird answers that you weren't expecting if you're comparing capitalized letters to lowercase letters. All right, so that's enough on relational operators for now. Pretty easy concept, but we can't get by without it when we're talking about decision making in computing, which is our next topic. See you in the next one.